Here we're going to talk about charge polarization. Charge polarization occurs most often with materials that are insulators. So this doesn't really happen with metals or conductors. During this charge polarization process, the material's atoms or molecules remain electrically neutral. Normally, an atom's centers of positive and negative charge overlap each other, but if a charged object is brought nearby, each atom's electron cloud shifts, and we now have what we call a polarized atom. Let's draw a picture of this and see if that makes a little bit more sense. If we had an atom without any charged object nearby, this could go for a molecule as well, but let's just say an atom. So there's the nucleus, and we might say, oh, the electron cloud is uniformly distributed, kind of like that. But you can see that the centers of positive and negative charge, I've only drawn one plus here, but we can assume that there is enough positive in the center here to cancel out the negative out here. But we do know that the positive is all in one place for an atom. The positive and negative centers of charge coincide. Now, if we bring a positive object nearby, let's say we put it on the left here. So here's our positive object. There's a plus sign. I'll make a big O, positive object. And here's our nucleus. It is repelled by this, but the nucleus doesn't really go too far. You got to remember that there are all kinds of other atoms in here, and those nuclei are pretty much fixed in place. However, the electron cloud for this atom here is not fixed in place. It can shift a little bit, and so it's going to shift a little bit closer to this positive object because it's attracted. And you can see now that the center of negative charge doesn't line up with the center of positive charge. The center of negative charge is slightly to the left here. This atom here is polarized. Similarly, if we were to bring a negative object nearby, once again, here's our nucleus, which, because it's connected to all the other nuclei, again, isn't really going to be affected very much by the attractive force that it will have with this negative object. But the electron cloud wants to get away. It is repelled, isn't it, from that negative object. And so here again, you can see that the positive and negative charge centers don't line up. This now is also a polarized atom. And so what you see here is this. This negative object has an attraction to this nucleus, and it's repelled by the electrons, but isn't the positive one closer than the negative? So there's a net attraction here. How about the middle picture? We've got a positive object, and the negative center of charge is a little bit closer to it than this positive is, which means there is going to be a net attraction here as well. That brings us to our final point for this video. It is this electron cloud shifting that makes a neutral insulator always be attracted to any charged object, which brings us directly to Coulomb's law, a subject for another video.